Okay everyone, so to start off again, we're back at this York startup. We already have all these RTUs started up, no problem. Economizers are wired in. Every thermostats are properly wired for heat pump mode. However, on this last heat pump, we found a low voltage short that was tripping this particular transformer. Now this one powers my low voltage unit control board here. So to figure this out, I wanted to isolate it, whether it was on the low voltage side or within the actual equipment. So what we did basically was reset the transformer after shutting off the power, and we isolated the low voltage and turned the unit back on. No tripping of the transformer whatsoever. So what that tells me is we have our short here in the actual low voltage. And what's happening is I am getting continuity between this black wire, your red wire, your common, and then your Y1, and I believe it was also between Y2. Not too sure on that, but however, either way, we still have quite a bit of shorts on here. More than likely we got a short with a strip through this MC. So we're gonna either try to find the short and repair it, or we're just gonna run a new line since this is a new project. So we're gonna come back and follow up on that one. All right, just so we can see what's happening here. So we have a good transformer, breaker's not tripped. Okay, so we're gonna repower this up. I wired back in my common and R, which should not trip this, but we're gonna turn this bad boy back on. Okay, introduce this and an immediate short. There we go, we see that it's tripped. Okay, so now what we're gonna do is let's just take this terminal block out. Okay, shut off the power. We're also going to reset our transformer, and then we're going to power it up back one more time. So let's take this one out too. So now that's completely free and isolated, and right away we did have a transformer pop on the first instance, and right now we are good. So we should see the countdown starting up. There we go. So now we confirmed that the low voltage short is in the wire or somewhere along the line. So we're gonna figure that out. All right, guys, so in finding out the short, this is the actual culprit. It was a splice that was made because some of the thermostat wiring was either nicked or was too short. I'm not too sure, but the problem here obviously is super apparent. We have a lot of strip wire, copper against each other. Definitely not a good splice. You want to cut back and only do the copper inside the wire nut and not tape everything together. So obviously this is quite a common mistake. Actually, you see it often on job sites and different places, residential, commercial. I've seen it quite a bit oftentimes. Obviously we're gonna talk to whoever we need to kind of do a little bit of more training and proper handling of this. And the reason why I was getting different shorts across all the different wires is, one, obviously it's not done correctly, but when it's taped together you start getting shorts all across the different wiring instead of just between maybe 2 or 3 lines. So we just go ahead and correct that. All right folks, so now we're back again here. We have everything rewired, new wire ran. I'm going to tidy this up here in a little bit just to confirm we're not going to get anything. However, I've already did a continuity test. We should be good to go. So we're gonna power this bad boy up, and we got power, no breaker trip here. Very good. Should see the UCB power up here in just a second. There we go, all good to go. So now the next thing we're gonna do here is we're gonna check the rotation of this compressor, which I've already done beforehand. So there's 2 ways that generally a lot of people like to do it. Some people like to recognize the sound of it running backwards. I don't really recommend that. Sometimes you can leave it running and people think, yeah, it sounds okay. I don't recommend it. I always hook up my gauges to it to make sure that it is actually pumping the correct way in either heating or cooling mode. Now, another thing with these York units, according to the manufacturer instructions, we have to check the high voltage here. So we have A, B, C, or L1, L2, L3, because we're working on a 3-phase system. we check for the high leg, which would be whatever the greater voltage is of the 3 legs, and that'll be connected to L2 or the B terminal block here. So once we verify that, we can hook up our gauges, make sure that the compressor is running correctly, and that should take care of that. And now just a quick test here. We're gonna press in the contactor and see the sound. Make sure here. Beautiful. Nice pumping compressor. Okay, so we verified that. Another thing that you can always check is making sure that the actual blower motor is running the proper way. And that's pretty much it. So we're gonna clean up here a little bit, and then we're gonna finish up for the day. Okay, a quick note here, guys, about the smoke detector wiring. There are different ways to wire this bad boy up. However, a lot of smoke detectors, you can only have one power source. Here on this project, we have the power being supplied by a separate circuit of 120 volts. Normally, if you want to power the smoke detector, you can use these 2 terminals here, SD24, SDR. This is the in and out of hot for 24 to supply power to the duct detector. However, since we are powered, we really would just want to break the circuit to the circuit board so we can turn off the compressor, fans, an indoor fan in case of a shutdown or an emergency. So here what basically we are doing is just we're gonna break the 24 volt hot leg to the UCB. As you can see, it's powered off right now because I'm testing smoke detectors. And that was just my quick tidbit on that. So guys, if you enjoyed this video, please like and subscribe. Let me know how these videos are helping you guys out. I do plan on posting more regularly as the season starts kind of warming up.